measurements, something like radar, then wind profiler, then radio occultation, then GNSS system, etc. So I will give only the introduction part of this particular topics only. Okay. So my advice is you just huge material is available in internet. Okay, so huge material is available. So at least you prepare for 1 or 2 pages of notes. You can use this material also. You can take notes and then you prepare a separate notes for at least 2 pages for each topic. So which will be helpful for your exam point of view. Okay, I'm not going to teach much this advanced technique, but at least you should know these are all the advanced level of techniques available for weather observations. Okay, so for that only we are covering this particular session. And if I've covered this session, then my part of the upper air instrumentation is over. And if any doubt or anything is there, you can discuss in the next class. Next class means tomorrow morning. And then that's all from my side. So tomorrow morning we will keep that session for doubt clarification only. I'm not going to take any new session tomorrow. So today is the last session for covering the upper air instrumentation. And this session, I am very clear, this is not sufficient for your exam point of view. So at least each topic, whatever I am going to cover here, each topic, you prepare a 2-page notes about that particular topic, each one page. So that is sufficient for your exam point of view. So questions may come, write brief notes about LIDAR, brief notes about radio occultation or what is wind profiler, something like that. Questions may come, either 5 marks questions or 4 marks questions they may ask. Okay, so but questions definitely I am sure questions will come. But if you prepare separately using that internet, etc., then you can able to very well answer, and that is sufficient for your exam point of view. Okay, right? So today we are talking about the various technologies available in the observation side. So the first one is LIDAR. So here also, like radar you might have studied in the same way we have LIDAR. So LIDAR is light detection and ranging. Okay, the simplification of light detection and ranging is called LIDAR. Similarly, radio wave detection and ranging is called radar. Okay, radio wave amplification, detection and ranging is called radar. Okay, so here instead of radio wave, we are using a light waves. Especially light wave means the laser light waves only we are using it. That is why it is called LIDAR. Okay, so it is a optical remote sensing technology. Okay, because we are using with light, that is why it is called optical remote sensing technology. And this particular thing, you need 2 different types of thing. One is you need a transmitter for transmitting the laser pulse or light pulse. Then you need a receiver for receiving that reflected pulse. Okay, or scattered, we can say it is instead of reflected, we can say that scattered pulse. Then you have to calculate the time delay, etc. Time delay depends on the atmospheric conditions. Then based on that, you can able to identify the range or the movement of the target, movement of wind. Then so many things you can perform with the help of LIDAR. Okay. Then so applications, you may be very well aware of it. It is used to generate a precise three-dimensional information about the shape of the Earth and its surface characteristics. Okay, so this is the shape of the Earth can be scanned with the help of LiDAR. The useful information for the geographers, policymakers, and conversationists and engineers. Okay, so you can scan the entire forest area with the help of LiDAR that may be attached with any aircraft or any choppers, etc. So that way also you can scan, and this can be keep in a ground tool to measure the range of some moving objects, etc. So that also possible. It has also have a potential tool of archaeological discovery, etc. So varieties of applications are available with respect to LiDAR. Okay. So the working principles, as I told, you should have a transmitter, then you should have a receiver, okay, and you should have a common, this is nothing but a target. So you have to transmit the pulse, it will go and hit that target or any atmospheric aerosols or anything, depending on the wavelength you are choosing, it will reflect or it will scatter. A part of the beam will come back to the receiver side. Then you have to take, when it was transmitted, when it was received. Then the time delay you can take. The path is nothing but the time taken to this target and return back. So if you add these two times, then divided by 2, then you will get a range also. Okay, and if you want to measure the Doppler effect also, you can identify the change of frequency in the pulse, received pulse, as well as the transmitted pulse. If you compare that, you can able to identify that. Based on that, you can able to identify the target movement also. So these are all possible. Okay, it is similar to radar only, but instead of radio waves, here we are using light waves. Okay. Then should be come to the control system and the acquisition system. Then that should be analyzed with the help of system. Then you can able to interpret the data depending on the application. But this diagram will give the information about the basic principles. Okay, you should have a transmitter, then you should have a receiver, then you have to actually put the signals, then you have to analyze the signal, you will get the idea of what the area, what the target is, right? So this is the basic principle. And how it is working, as I already told, the distance or the range calculation is nothing but, so this light waves is also travel along the speed of electromagnetic waves. So that is nothing but roughly you can say 3000 kilometers, or you can say 2.9 meter per second. Okay, kilometer per second. Okay, so that is nothing but speed of the light. Okay, speed of the light. So roughly 3 lakh kilometer per second. Okay. So that speed of the light into time of the flight. Time of the flight is nothing but traveling time to the target and returning time or standard wave returning time to the receiver. So twice the path it was traveled. That is why divided by 2. So you can able to see the distance or range of the object. So that you can able to find out. Okay. Then here the LiDAR transmit 2 waves, online wavelength that is absorbed by gas and offline wavelength that means it is not absorbed by the area of interest. Okay. So if you in the atmosphere, if you take atmosphere, then atmosphere consists of huge amount of gases are there, nitrogen, oxygen, so many things. So if you select some wavelength, then some of the wavelength may be absorbed by a particular gas like CO2 will absorb in some range. Then water vapor will also observe in some range. So you have to identify that wavelength and window channels. Then depending on that, you have to use that particular wavelength for absorption or differential absorption, etc. Okay, so Doppler radar and Rayleigh Doppler radar are used to measure the temperature and the wind speed along the beam by measuring the frequency of the backscattered light. Okay, and velocimetry also you can able to identify the wind speed, turbulence, and bearing wind shear data, etc. can be measured with the help of lidars. Okay, so these are all some basic introduction about lidar only. Okay, so my request is you can take this basic information and prepare at least 1 to 2 page separate notes. Okay, notes are available, so that you prepare and then you can use it for your exam point of view. Okay, so that's what my suggestion here. And here, what are all the things you can able to identify? You can identify the atmospheric molecules, cloud droplets, aerosols. Okay, so all these things you can able to measure. At the same time, you can see that horizontal wind speed, the direction of radar beam, and also you can able to identify. Okay, but vertical wind speed means that is it will not measure that vertical wind speed. It will measure that horizontal wind speed depending on the ray where it is going. If it is going with vertical or it is going with horizontal, so that depends, right? Then similar to LiDAR, we have another technology that is also wind profiler. So wind profiler means this is also the same technique, but here we are using a radio waves. Okay, so here we can choose some particular frequency and we will transmit it and we will receive it. Okay, here also we need transmitter and receiver for wind profiler also. And if you see that, and you can able to identify the different atmospheric conditions of over and of that particular, and you can change the angle of transmission, and then you can able to cover some particular area over the region of that particular wind profile. So that is also possible. And the only difference between this wind profiler and this radar is using light waves, and here it is using radio waves. Okay, and here in India, some of the places we have wind profiler, different purposes. One is the tropospheric wind profiler is there, boundary layer wind profiler is there. Okay, and in nearby our Chennai, Tirupati, Kadangi is also we have wind profiler and MST radar is also there. Okay, and here the concept is the same. It will transmit a pulse depending on the atmospheric condition. It will reflect back. The backscattered signal will be received by the receiver, and then that signal has to be processed by the processor. Okay, then you can analyze the data, then you can able to plot the wind like that. Okay, you see that with the different instant of timing in x-axis, and this height is in y-axis, and you can able to see the wind at different levels and wind speed and wind direction, everything you can able to see with this data, output data. Okay, so here you can see the wind speed, wind direction at different instant of time. What is the advantage of this one over the radius and day? Radius and day you have to use huge money, and then that can be taken only twice. Okay, 2 times, the morning and evening. But in wind profiler you can operate it continuously, and you can observe instantaneous wind with respect to your operation timings. Okay, so that what is that advantage? Continuously you will get a data of over your atmosphere. So that will help us to identify the wind pattern over any airfield or any airport, the boundary conditions. etc. So that will be very, very useful, and this data can be just into the NLP models directly, so that will improve the quality of a forecast product. Okay, so because it is a real-time observation, so all these things you can do, and this wind profiler data will give up to some height only. So it means you can go for 60 kilometer or 20 kilometer, depending on the wavelength and etc. you are choosing. Then you can able to get that information. Okay, so in my suggestion, you prepare a 2-page note for radar and prepare a separate 2-page note for wind profiler. Then you can understand the difference and then advantage, then what are all the parameters you are observing from radar and then you are observing from wind profiler, right? So I have given some details related to microwave radiometer here, and then microwave radiometer, the frequency band which we are using in the K band and V band, and the temperature sensing channel is V band is 50 to 60 gigahertz. Number of channels used is 21 channels or more, and the humidity sensing is also K band and 22 32 gigahertz, and number of channels which we are using here is 14. Okay, and the sampling time is 20 seconds or better. Okay, so this is the specification of the microwave radiometer. Then high coverage is at least up to 10 kilometers we have to cover, and vertical resolution is 100 meters or better, below 2 kilometer, and 500 meter or better for above 2 kilometer. And the accuracy of humidity is 3%, resolution is 1% or better, range up to 0 to 100% humidity range. Okay, so that humidity you can able to measure with the help of radiometer. The temperature range is -50 to +50 only, but in our tropospheric atmosphere itself it will go for 16 kilometer it will go up to -80 plus, -80 or 85, so that it have a limitation of up to 10 kilometer range. Okay, so that you have to understand. An operating condition -32 plus 50, sorry, 32 50, and relative humidity is 0 to 100. Okay, so environment condition, any environment condition, you can able to use this radiometer. So this also you can compare. And similarly, wind spectrometer. Wind spectrometer is very useful for measuring a wind over the sea area. Okay, so it is wind spectrometer is kept at the satellite. Okay, mostly this polar orbiting satellite, all polar orbiting satellite is having the wind spectrometer, and using this data you can able to take the surface level wind also over the ocean. So that data is very, very useful for our forecasting as well as plotting, then analysis of the three-dimensional view over the globe, etc. Okay, so this is also very important, one of the important observation which we are in real time we are using it, and this data is fed into the NLP models also. Okay, so this data is also very useful. So what you have to do first, you have to prepare a notes for data, you have to prepare a notes for wind profiler, then you have to prepare a notes for the wind radiometer, then spectrometer. Okay, wind spectrometer. I have given something but which is not sufficient for exam point of view. So you try to take little more material regarding this one. 2-page preparation is sufficient. Okay, so spectrometer is similar to radar only. Okay, and it will be transmitted microwave energy from the satellite, and it will be backscattered from the surface to our blue panels. It has to receive over the ocean. Person one form. The backscattered signal from the surface as well as the sea waves. Okay. You may be knowing that depending on the wind condition, the sea waves will be generated, and depending on the wind speed, the amplitude of the sea waves will be different. Okay, higher the wind speed, then the waves height will also higher. Okay, so with respect to this height of these waves, that will be reflected in a right angle. Okay, so that waves will be reflected. Whatever waves comes from the scatterometer, that will be reflected by this wave. Then that backscattered signal will be captured by the scatterometer, and it will analyze the signal. After analyzing it, we can able to see the wind speed over the sea surface area. But we can say it is a surface, but the actual scatterometer value is 0 to 10 meters, above 10 meters range, depending on the wave height, etc. Okay, so that level you can able to take the wind over the ocean. So you may be knowing. 1 minute. I will. So the wave amplitude, depending on the wave amplitude, the backscattered signal strength will also increase then with respect to the wind speed. Okay, so indirectly it can measure the wind speed with respect to the wave amplitude and backscattered signal strength, etc. So that can be plotted. Okay, so this is the concept of this wind scatterometer. So the scatterometer is also placed in the low orbiting satellite. So from there you can able to get the wind. Okay. So the entire global observation is possible because if it is a low orbiting satellite, means global observation is possible, and you have a swath range of 500 kilometer. Swath range is there. Then, if you see that the vertical signal, it will transmit from the scatterometer. Then the reflected signal will also go. So there are three beams, four beam, mid beam, and after beam. All these things you can collect it. Then you can able to plot it. Okay, so this way it will scan. But if you see that speed of that rotation of satellite is very high. Okay, even for over the Indian region, just 20 minutes period it will scan from 10 degrees south of equator to 30 degree north of equator. You just see 1 degree is roughly 110 kilometer. So it will cover within 20 minutes about 40 degree. 40 degree means for the 40% kilometers it will cover. Okay, so roughly 4,000 kilometers it will cover, and it depends on the swath area also. Okay, in the next scan again it will cover. So that if you combine all the scans of that particular satellite, then you can able to see the entire global data also. Okay, so that is possible with the help of spectrometer. Here I have given some details. This you can take, or you can take it from the theoretical part, how the signal is observed over the ocean surface, etc. That you can study. Okay, so a lot of things are there that you can take, and if you see this, the wind observed over that particular scan, you see that this is one particular cyclone was there, Typhoon Shaoli. So this particular typhoon, how it is observed by that spectrometer wind, and that can be plotted. Okay, so every scan of that particular satellite, you can able to get this type of wind observation, but only particular swath area, roughly 500 kilometers, or it depends on that angle of injection, etc. Generally, the METOP satellites scan for cloud observation, etc. It will go for nearly 2,000 to 2,300 kilometers. Okay, but here it's about 500 kilometers range. So the entire cyclone range will come with one single scan, and it will cover only a few minutes. It will cover the entire range of area. Okay, so this is very useful. So real time, we are using this spectrometer data for developing models, etc. And this particular observation was done from the METOP satellite. And in our observatory earlier, we have received these data directly. Okay, so we have a facility at Chennai, then Delhi, and Guwahati. We had a facility. Now the system is some issue is there, so it is unserviceable. And if it is once serviceable, and we have formed a committee to review that particular system. If it is received, then review, then we can able to receive the data directly from METOP A satellite. So METOP A, METOP B, these are all the two satellites we can receive from the European Union side. And then NOVA 18, NOVA 19, now it may be NOVA 18, 19, 20, now it may be 21, 22 may also be available. So all these satellite data you can directly receive from our system. Okay, and China's Shenyang satellite data is also we have received. So we had that facility, and we can able to receive this data, and using that data we can forecast anything. And this is that particular cyclone. Okay, so over that cyclone, how the wind is there. So all these things you can do. Because it is a low Earth orbiting, or you can say polar orbiting satellite, so that when compared to geostationary satellite, the satellite height is very low, and accuracy and clarity is much more than geostationary satellite. Okay. Then another thing is called optical spectrometer. So this optical spectrometer, we are using it in our airport. So here, instead of that radio waves, we are using a different waves, laser light range. We are using it, and we are using another receiver as a photodiode, so that whatever this radar laser light is illuminated, it will go and hit that atmosphere, like how transparent that atmosphere is. If the atmosphere is dense, fog, etc., then the return signal strength will differ. Okay, so based on that, we can able to see the visibility condition of the atmosphere. Okay, and this optical spectrometer we are using in place of transmissometer. So transmissometer is also give the visual transparency of that atmosphere. Based on that, visibility will able to measure. Okay, same way only here also we are using that laser optical spectrometer for that particular purpose, and using a photo detector we can able to detect that signal, and we can indirectly measure the visibility of the runway. Okay, so in our airport also, so this is that particular instrument. We have a receiver, we have a transmitter. So these two are it will simultaneously transmit and receive the based on signal strength. You can able to see the visibility condition of that atmosphere. This is installed in our Chennai airport also. And if you ask the okay, which is better, say for example, this will also give value of visibility. Okay, and transmissometer will also give the value of visibility. Then which is better? So obviously transmissometer is better. Why? Because transmissometer, the sampling area is very high. It means we have a transmitter and receiver within a range of 15 meters, sometimes 30 meters, sometimes 60 meters or 45 meters. So different range of receivers we will set and we can receive. So that in the 50 meters, at least 30 to 50 meters range, we will sample it and we can able to give the visibility condition. But in this particular thing, you can see that the range, the distance between the transmitter and receiver is very minimum, and something like a small area only. So this area visibility depends on the atmosphere presses over this area only. So that this may be incorrelate with the real atmosphere, or sometimes depending on the condition of that atmosphere, this may deviate. Okay, so so if you ask that question, which is better, transmissometer will be highly reliable than this scatterometer, because this is a optical type of thing. The sampling reason is the sampling area is very minimum. That is the reason. So this we are using it in our airport runways. Okay, Chennai. And another technique is radio occultation technique. Okay, so this radio occultation technique is okay. How we are doing it? So we have three different sets of satellite. One is low Earth orbit satellites, or you can say polar orbiting satellite. Another one is geostationary satellite. Okay, and the third set of satellite is GPS satellite. So the height for the GPS satellite will be covered around 26,000 kilometers to 28,000 kilometers. Geostationary satellite is about 36,000 kilometers. And low Earth orbit satellite, it revolves around 2,000 to 3,000 kilo. Okay, so that the signal which is received from this GPS satellite, that signal will be bent depending on the atmospheric conditions. Okay, so atmospheric conditions means the transference of atmospheric conditions will vary. Due to that, reflective index of that atmospheric condition will vary, and depending on the refractive index, the signal will bend. So from that, we can able to measure the values of that atmosphere. So that is what it is called radio occultation. You see that how the signal is. This is GPS satellite, and this is low Earth orbiting satellite, METOP series. Okay, so not only METOP series, so many NOVA series is also there. Then Phoenix series is also there, and our in Indian satellite is also there. Okay, so this concept is the signal which is coming from GPS, that is about 26 to 28,000 kilometer, and here low Earth orbiting satellite is about 1,500 to 2,000 kilometer height, and you see that the signal is bent due to refractive index, and it is reaching this particular satellites. So how much it is bending, depending on that, you can able to see that refractivity due to stratosphere, then temperature and moisture due to troposphere. Okay, so in the stratosphere only temperature, and in the troposphere the moisture will be there. So moisture and temperature. So the profile of this temperature profile and moisture profile you can able to take with the help of this radio occultation, so that this signal is compared with our radio Sunday observation. Okay, so the radio occultation signal profile, temperature profile as well as the humidity profile was compared with our radio Sunday data. But it is not exactly equivalent to our radio Sunday data, but 1 or 2 degree variation was there in temperature, and moisture is also slight variation was there. But it is acceptable level. Okay, the data which we have received is acceptable level. So that but what is the advantage? Advantage is this data will be available very frequently when compared to our radio Sunday data. Radio Sunday data will be available only twice in a day, but this is available every satellite pass. You can get this profile of temperature, profile of moisture, etc. So that it is very useful. Okay, so in future this type of technology will improve more and more, and then the usage of radio Sunday data may be slightly reduced, or this data will we cannot say as of now replace the radio Sunday, but it can also be utilized for our data classification. Okay. This is the delay, how it is happening. From the GPS satellite, ionosphere entrance, then it will come to the neutral atmosphere, etc. So the concept of that particular delay, which was represented here. Okay. Then you can able to get the profiles like that. Even you can get the temperature profile, you can able to get the wind profile, and then up to what level you can able to get this profile. This profile may get up to 25 to 30 kilometers height. You can able to get at different vessel levels. Okay, so that it will be very useful observation. And another observation is ground-based GPS observation, and this system, GNS system, Global Navigational System, and this system is also installed in our observatory. If you see that next to our surface observatory, we have a GPS system. So that is the ground-based GPS system. This system will also receive the signal from the GPS satellite. Okay, but the GPS satellite signal is delayed due to, okay, this is the make of GPS. The delayed due to, if you see that, 2 types of delay. Okay, what are the 2 types of delay is there? One is atmospheric delay, which is called wet delay and dry delay. Okay, so only 2 delays are there. So if you see that wet delay is very minimum, only the dry atmospheric delay, that is due to ionospheric delay only there. So you have to calculate the ionospheric delay. With the delay depends on water vapor available. Okay, so ionospheric delay depends on the water vapor available. The water vapor availability is more than the corresponding delay availability, and if water vapor availability is less, then the corresponding delay is less. So based on that, you can able to calculate the integrated acceptable water. Okay, so you can collect the integrated precipitable water vapor. So that data will also available depending on the satellite pass. Okay, so this data is very very useful, and this is also we are using it. Okay, and another here, not another
అప్డేట్ చేస్తారు టైం
this
పడుతుంది.
delay. So here, if you see the differential GPS calculation, and this differential GPS calculation, we are using it in our radius ante also. So in the radius ante, I already explained. We have
రేపు వస్తాను సార్
what
అది యాక్టివేట్ అయిపోతే
GPS
రేపు వస్తాను సార్
receiver
అని చెప్పు.
the
బిల్ చేసుకున్నావు
Sunday,
చెప్పు.
as well as
ఎప్పుడు
we
రమ్మంటారు
have
సార్
a
అని చెప్పు.
GPS receiver at
చెప్పు
our
ఎందుకంటే
station. So that you see that at station, say for example, if you think this is a station, this is a balloon, or a person moving, then you can able to calculate this different same satellites from the same satellite. You will receive the signal by the moving parts as well as the stationary GPS. So if you measure the actual measured data, then subtract this one, then you can able to get the differential GPS. This is very accurate that independently measuring one GPS signal with respect to any region. Okay, so that way you can calculate the differential GPS also. So various advanced technologies are also evolving for measurement of that atmospheric parameters. So almost I have covered the different techniques which we are as of now available. So the first one is LIDAR, then the second one is I have covered advanced topic is wind profile, and the third one is radio occultation. Okay, and the fourth one is ground-based GPS receiver. Okay, so all these things are very important and advanced techniques. Okay, so they may ask right sort modes of wind profiler, right sort modes of LIDAR, right sort modes of about ground-based GPS, or what is radio occultation, something like that. You can ask questions. Definitely, questions will be there from this particular session. If you want to score full mark, then you prepare each of this topic with 2 pages. Okay, not more than that. 2 pages is sufficient. You sit in net, and then you collect that information, and whatever information I have shared with you, that is also you can utilize it, and then prepare the notes. That is sufficient for this one. Okay, so that's all for career instrumentation part. And tomorrow we will have one more class. We will discuss if any doubt is there. We will discuss. Then that's all from my side for career instrumentation. Almost everything I have covered. Okay. Right. Any questions?